All right, welcome back to Chapter 7. This is Section 7.4. This is evaluating exact. Okay, so the key word here is exact sine, cosine, and tangents of angles. Okay, so basically what you're going to do is everything that you memorized off of the unit circle in Algebra 2, you'll now know how to do how they got these numbers. Not just what the numbers are, but actually how these numbers are achieved. Okay, so let's get right into it. All right, first thing we're going to do is we're going to figure out how to find approximate trig values of angles. Now, approximate means you're going to use your calculator. Okay, oops. So approximate means using your calculator. So if the book says to find approximate values, then you're just going to use your calculator. These are super simple. All right, the first one says sine of 122 degrees. All right, so I'm going to go to my calculator. Now, if you hit the button right next to the blue one, it says mode. And if you notice, there's radians and there's degrees. You want to make sure you're on degrees because my problem is in degrees. Okay, so it says sine of 122 degrees. My answer is 0.848. So always go out to at least two decimal places. So 0.85. So 0.85 would be my answer for this one. All right. Next one, same thing. We're in degrees. We're doing cosine of 237. So I go to my, that. Cosine of 237 degrees is negative 0.54. Negative 0.54. Okay, now what do you notice about the next two? The next two are not degrees. They do not have degree symbols, so we have to switch our calculator to radians. So you go to mode, and then you're going to go down to radians, hit enter on it, and that will change your calculator to radians. Okay, so let's do this one. Tangent of 5. Okay, negative 3.38. Negative 3.83. Let's just double check that. Oops, I had it backwards. It is negative 3.38. Okay, the second one now is sine of negative 2. Don't get confused. It does not have a degree symbol, so we're still in radians. So this one says sine of, let me get rid of everything here, sine of negative 2 radians. Answer is negative 0.91. Negative 0.91. Negative 0.91. Okay, now, what happens if they asked you to do this problem? Let me just make one up here. Tangent of 3 pi over 4. Okay, so is this degrees or radians? Hopefully you recognize that that's radians. You can still do this on your calculator. Okay, we're going to go back to our calculator now, and we're going to do, let's see here, tangent. Let me get rid of everything first. Tangent of 3 pi, I got to put 3 pi in parentheses, sorry. I'm going to put 3 pi in parentheses divided by 4, and then close your parentheses. Okay, and my answer is negative 1. So that is how you find approximate answers. Decimal answers are approximate answers. Okay. All right. So now we need to figure out how do we actually find exact answers. Okay. So we need to be able to find a reference angle. This is a very important word. You need to be able to find a reference angle for the rest of this chapter. All right. It says the smallest angle that the terminal side of a given angle makes with the x-axis. Now that probably isn't going to make a whole lot of sense. Okay, so let's find the, I'm going to abbreviate, let's find the reference angle of 210 degrees. Okay, 210 degrees. All right, so let's first go, let's draw 210. Okay, there's 180. And then 180 plus 30 more will give me my 210. All right, so there's my 210 degree angle. Now, the reference angle is the distance from the terminal side okay, which is right here, right? Here's your terminal side. It's the distance from that terminal side to the nearest x-axis. And remember, the x-axis is either over here or here's the negative x on the left. It's the distance from this terminal side to the nearest x-axis. So how much further past 180 am I to get to 210? So 210, basically you do 210 minus 180, and I should get 30 degrees. So my reference angle is 30 degrees. Okay? That's a very important number here. All right, so now let's find the reference angle of, let me just make one up here, 70 degrees. Let's find the reference angle of 70 degrees. Okay, so I'm going to draw 70 degrees first. It's kind of ugly, but that's all right. All right, so now the reference angle is the distance from the terminal side, which is that last line, to the nearest x-axis. Well, which one am I nearest to, the positive x-axis or the negative x-axis? Well, I'm closest to the positive one. What is the reference angle of 70 degrees? How far is that line from the x-axis? Well, if you're in the first quadrant, the reference angle is just whatever the angle is. So the reference angle of 70 degrees is 70 degrees. All right, so we've done a first quadrant, we've done a third. Let's try a second quadrant one. Okay, so let's find the reference angle of, let's see here, 110 degrees. Let's do 110. All right, so I'm going to draw 110. There's 90. I need a little bit past 90. All right, so how far is this terminal side here, this whole terminal side, from the nearest x-axis? Well, if you're on the left, your nearest x-axis is this negative x-axis. So how far is this angle from 180? Okay, so how would I get that? 180 take away 110 is how much? Hopefully you see that that is a 70 degree angle. So my reference angle for this one is 70 degrees. Okay, so how do I get a third quadrant? It's the angle minus 180. In a second quadrant, you do 180 minus the angle. In the first quadrant, it's just whatever the angle is. And now let's do a fourth quadrant. So let's say we had 290 degrees. Okay, 290. So here is 180. Here's 270. I need to go 20 more degrees. So there is my 290 degree angle. Now the question is, how much further is it to get to the nearest x-axis? So how would I get this one? 360 minus your angle. Okay, so what's 360 minus 290? Hopefully you see also that that is a 70 degree angle. So the reference angle here is 70 degrees. Now notice reference angles are always positive. They're always positive. Okay, so there are my 4 examples of a first, a third, a second, and a fourth quadrant angle. Okay, so we need to be able to find reference angles. Now, here are the 3 important reference angles that we need to know. Okay, we need to know 30 degree reference angles, 60, and 45. And these are the measures of the triangles for all 30, 60, 45 triangles. Okay, so, and we'll do more of these later. Okay, but for right now, they're on your note sheet, and we'll come back to them. But and notice though that these are all in the first quadrant. Okay, our angles are not always going to be in the first quadrant, but the triangles are. And I'll show you how to maneuver these when we do some examples. All right, and notice now, if we look at the actual unit circle, we have a 35, 45, 60. Each quadrant is broken into 30, 45, and 60 degree reference angles. 120 is 60 degrees away from 180. 135 is 45 degrees away from 180. 150 is 30 away from 180. So there's my 30, 45, 60 angles in the second quadrant. 210 is 30 away. 225 is 45 away. 240 is my 60. So the whole unit circle is broken down into 30, 45, and 60 degree angles. That's why these 30, 60, 45s are important to us. Okay, And what these triangles give us are all of these ordered pairs. They give us all of these ordered pairs around the unit circle, these important numbers. All these numbers are your sine and cosines. Okay, so let's do an example. Let's finally figure out how to do this. All right, so it says find the sine of 150. Not plug it in on your calculator. Find the exact. Okay, find the exact measure of 150 degrees. Okay, so what you first should do to get used to these is draw your angle. All right, so I think that's approximately 150 degrees. Okay, so basically what we have to do is draw the angle, and then we need to find the reference angle, the distance to the nearest x-axis. So 150 is how far away from 180. Well, hopefully you see that this is 30 degrees. Okay, so we are using, oops, wrong thing there. So we are using which one of our three triangles, the 30, 45, or 60? Well, this is a 30-degree angle. So we are using our 30-degree triangle in which quadrant? Okay, hopefully you see that we are in the second quadrant. So I'm going to draw my right triangle in the second quadrant. I'm going to label it a 30. Okay, so now let's go back. This is a 30-degree triangle in the second quadrant. Now if we look at our triangles, here's our 30-degree triangle in the first quadrant. What is the x value in this triangle? If you notice, it is square root of 3. Okay, now for our triangle, however, we went to the left, so we have to have negative square root of 3. Okay, let's go back. What's my y value in my 30-degree triangle? Hopefully you see that it's 1. In this problem, we are still going up, so it's still positive 1. And if you notice in all of the triangles, what is the hypotenuse? The hypotenuse of all these triangles is 2. So that never changes. So our hypotenuse is 2. Okay? Now, what does it want? It wants the sine value. From the last section, you realize that sine is y over r. Okay? Or you can just do opposite over hypotenuse, just like SOHCAHTOA. All right, so here's my important angle. Here's my important angle, 30. Opposite is 1. Hypotenuse is 2. So the sine of 150 degrees is 1 over 2. Okay? Now, if we go back to our unit circle now, and I get rid of all the markings, the sine value, sine is always your y value, and cosine is always your x value. So if we find 150 degrees, here's our ordered pairs. What is our y value here? It's 1/2. That's our sine. Isn't that what we figured out? Yep, we got 1/2, so we know we got the correct answer. All right, let's try another one. Cosine of 300. All right, I'm going to draw 300. Oh, it's probably about right there. Okay, there's 300. Now I need my reference angle. It's the distance to the nearest x-axis. How far away is 300 from 360? Remember, this is 360 and this is 300. So how far is that away? Hopefully you see that that's 60. Okay, so now I'm using my 60-degree triangle in which quadrant? Okay, I'm in the fourth quadrant. So I'm going to draw a 60-degree triangle in the fourth quadrant. It doesn't need to be precise, it just needs to be a right triangle in the fourth quadrant. Okay, now I'm going to go back to my triangles, and we're going to figure out what our dimensions are. Alright, so 60 degrees. My x value was 1, and we went to the right. So here, we're still going to the right, so my x value is still 1. My y value is square root of 3, but we went up. So what do we have to do on this one? Now we are going down, so it's a negative square root of 3. And the hypotenuse is always 2, so that doesn't change. Okay, now all we have to figure out now is we are finding cosine. Cosine is x over r or adjacent over hypotenuse. Okay, so if this is my important angle, 1 is my adjacent and my hypotenuse is 2. So the cosine of 300 should be 1/2. Okay, let's go to our unit circle. Find 300. find 300. And what do we get here? Oops, that's the wrong one. I find 300s right here. And the cosine is your x value. What should it be? Okay, x equals 1/2. Perfect. That's what we got. All right, so let's try one more here. Tangent of 225. I'm going to do 225 first. Okay, there's 180. Okay, and I have to go another amount to get to about 225. Okay, my reference angle is the distance from here to here. Okay, so what's 225 minus 180? Hopefully you see that that is a 45-degree angle. Okay, so my reference angle is 45 degrees. All right, so I have a 45-degree triangle in the third quadrant. So I'm going to draw a right triangle. So 45 here, and let's look at our triangles. Notice my x and my y are both square root of 2. Okay, so we just have to make sure we get our signs right. So my x and my y are square root of 2. We went to the left, so it should be negative square root of 2. We are going down, so it should be negative square root of 2. And remember, hypotenuse is always 2. Okay, what's tangent? Tangent is from the last section, y over x, or opposite over adjacent. SOHCAHTOA, T-O-A. All right, so what is this? Opposite. So here's my important angle. Opposite is negative square root of 2 over adjacent, which is negative square root of 2. And hopefully you see that negative root 2 over negative root 2 is positive 1. Positive 1. Okay, so can't really check that on the unit circle, but I will talk more about this at a later time. All right, and lastly, I want to talk about 90, 180, 270, and 360. So I want to talk about 90. Let me actually change my color here. I'm going to talk about 90 degrees. I'm going to talk about 180 degrees. I'm going to talk about 360 degrees. And down here, I'm going to talk about 270. So always remember that these are angles right on the axes, 90, 180, 270. The ordered pair here is 1, 0. The ordered pair here is 0, 1. The ordered pair here is negative 1, 0. And the ordered pair here is 0, negative 1. Remember, the highest sine and cosine can go are 1 and negative 1. Okay? So as long as you can remember these numbers, so this is for 360 or 0 degrees, and this is for 270. Okay, so as long as you can remember that all the ordered pairs are either 0, negative 1, or 1, you should be okay. Okay, and then the last thing you need to remember is that cosine is always x, sine is always y, and tangent from the last section is y divided by x. Okay, so I'm actually going to copy this down on the next page. And we're going to look at this a little bit further. Okay, so this is a chart that you should have memorized or you should have written down. All right, so let's find the sine. Let's find the sine of 90. Okay, so here's 90. The ordered pair is 0, 1. Sine is y value. What's my y value? 1. Done. These are easy. Let's find the tangent of 360. Remember, tangent is y divided by x. Well, where's 360? Here it is. My y value is 0. My x is 1. What is 0 divided by 1? Hopefully you see that's 0. So if you were to type tangent of 360 on your calculator, oops, I'm going to change my thing to degrees. So if you typed in tangent of 360, there it is, 0. Sine of 90, let's do sine of 90 like the one that we just did. 1. Okay, so these are easy. Last one. Let's do the cosine of 270 degrees. Here's 270. Cosine is x value. What's my x value? My x value is 0. 0. There it is. There's my answer. Okay, so that's section 7.4. We'll make sure we do more of these in class. Hopefully this wasn't too bad for you. I will see you tomorrow. Have a good night.